Hello viewers, welcome to this class. This is Teacher Nicholas, and today we want to have a very interesting lesson concerning the volume of polygonal cross-section prism. In the last session, we looked at the volume of a prism, general volume of a prism, and we say that the volume of prism is given by cross-section area. The volume of prism is given by cross-section area multiplied by length. So in this session we want to look at the volume of polygonal cross-section prism. Polygonal cross-section prisms. Polygonal cross-section prism. We have different types of prisms. We have triangular based prism, we have square based prism, we have rectangular based prism, and also circular based prism. Triangular based prism is part of this. Rectangular based prism is part of this. So we want to give more examples concerning this. And before we continue, first of all, we need to understand what we mean by a polygon. What is a polygon? What is a polygon? A polygon is a plane figure with at least 3 sides, and the sides are made up of lines which are connected end to end. So a polygon is a plane figure with at least 3 sides, which are made up of straight lines connected end to end. So that is what we mean by a polygon. It is a plane figure with at least 3 sides. It has many sides. Triangle is an example of a polygon with 3 sides. Quadrilateral is a polygon with 4 sides. Pentagon is a polygon with 5 sides. Hexagon is a polygon with 6 sides. We have heptagon, which is a polygon with 7 sides. Another one is octagon, 8 sides, nonagon, 9 sides, and decagon with 10 sides. So sometimes you may be given a prism whereby the cross-section area is a polygon. So how do we get the volume? To get the volume, it means that we're going to look for the area of that polygon, and then we multiply by the length or the extension. So we are going to do some examples. For example, you can be given an example like this. So these are polygons with how many sides? 1, 2, 3, 4, 5, 6 sides. So we have to get the area of this, and maybe it has some extension like that. So you are told to find the volume of this solid. So what do? We have to look for the cross-section area. We have to look for the cross-section area, this cross-section area, which is the polygon, and then we multiply by the extension. This will be the extension. This is the extension or the length. And before we do that, we need to understand that polygons can be regular or irregular. Regular polygons are polygons whose sides, these are polygons with equal sides and equal angles. So a regular polygon is a polygon with equal sides and equal angles. Irregular polygon is the one where the angles are not equal and also the sides are not equal. So what we are going to consider today is the volume of polygonal cross-section, whereby the polygon is a regular polygon. So we have some examples whereby we are going to do together, and I hope you are going to enjoy it. Cross-section prism. Volume of polygonal cross-section prisms. An example is, you can do one example. So we have this example. To find the volume of a regular hexagonal nut of side 5 centimeters and height 3 centimeters. So how do we do that? So first of all, we can do this by illustrating with a diagram. And the way we can, the easiest way of drawing a polygon is we can draw a circle like that, and then we can subdivide into the number of angles. We know that hexagon is a polygon with how many sides? 6 sides. So I can count 1, 2, 3, 4, 5, 6. Just a sketch. Then now I can join this. So this is an example of the hexagon, and even though it's a sketch, but it is a regular. We are told that it is regular, meaning that the angles that is the angles between the lines are equal, and also the sides are equal because it is regular. We say that a regular polygon is the one where the sides are equal and also the angles are equal. So we are told that this is a nut where the cross-section is hexagonal. So this is the cross-section area. This is the cross-section. So, and the height is the extension. We can extend it like this. So that is the extension. So it is something like this. And so it is something like this. Like this. So what we are going to do, so this is the height or the extension. It is 3 centimeters. And you're told that the side or the length of one side is 5 centimeters. So this is 5 centimeters. So what we are going to do, we are going to subdivide this polygon into, so it is like that. One, two, 3, 4, 5, 6. So we're going to subdivide. We want to get the area of this plane. So what we do, this is the center, and then we can subdivide it into triangles. So this is like that. And it is important to note that the number of sides is equal to the number of angles. Is equal to the number of angles. The number of sides is equal to the number of angles. Like now, here we have how many sides? We have 6 sides, and also the angles are 6. So what you can do, this is the center. You can take this as center of the polygon, because as I have been drawing, you saw that I drew a circle and then I subdivided it to form out a polygon. So at the center here, we know that angles at a point is equal to, add up to 360 degrees. Because these angles here add up to what? 360 degrees for a complete, for a circle. But now we want to know each angle. I mean the angle at the center of each triangle. This angle here, we need to know. How can we get it? This is a regular polygon, meaning that even these angles are equal. So we're going to divide it by the number of sides, or the number of angles. 1, 2, 3, 4, 5, 6, which is the same as the number of triangles. So we'll say 360 divided by 6. By this one, by this 6, which is equal to 60 degrees. So this angle here is 60 degrees. The same case applies to this. It is 60 degrees and so on. And we are saying that this side was how many centimeters? It was 5 centimeters. And again, we know that these lines here, the line that join the vertex of the triangle and the center, are the radii of the original circle. They are the radii of the original circle. So they are equal. So these sides are equal. And if these sides are equal, then it means also this triangle here will be an isosceles triangle. And what do we know about an isosceles triangle? We know that the base angles of an isosceles triangle are equal. So if these sides are equal, then it means also this angle here and these are also equal. So how can we get these base angles? We can say that 180 minus 60, because we know that angles in a triangle add up to 180. Angles in a triangle add up to 180. So 120 minus 60, which will give us, 180 minus 60, which will give us 120. And because we have two base angles, then now we can get what? It means that it is 60. So this one here is 60 degrees, and also this one is 60 degrees. So what can we? So here, a triangle where all angles are equal, that is 60 degrees, this is 60 degrees, also this is 60 degrees. So it means that this is an equilateral triangle. This is an equilateral triangle. That means also if the angles are equal, also the sides should be equal. So if this is 5 centimeters, even this one is 5 centimeters, and this one is 5 centimeters. So for us to get the area of this polygon, we need to have to know the area, to calculate the area of one triangle, and then we multiply by the number of triangle, which is the same as which is equal to the number of sides. That is, we'll have how many triangles? 1, 2, 3, 4, 5, 6. So how can we get the area of this triangle? We know that we have different methods of getting the area of a triangle, but one of them, you can use Hero's formula. You know that you can use Hero's formula. You can use half AB sine theta, or you can use a half base times height. So here we can use any. So the one that we can use is, because this is a Form 2 topic, we can use this one here. A half AB sine theta, where sine theta is an included angle. So what we can do, we can take this to be our theta. So to get the area of this triangle, we will say 1/2 times A, this is our A and this is our B, times A, which is, what I say, which is, so it is 1/2 times A, which is 5 times 5 sine 60 degrees. So if we work out that one with our calculator, we will get 1/2 times 5 squared sine 60. So this will give us 10.82, 10.83. 10.83 centimeters squared if you give in 4 significant figures. So this is the area of one triangle, and to get the area of the sixth triangle, we are going to say 10.83 times 6. 10.83 times 6. 10.83 times 6. This will give us 64.98. That will give us 64.98. So if you have so this is now the cross-section area of this figure. So now to get the volume, now, you know that volume is equal to cross-section area times length, or height or extension, provided you know which is the cross-section area. So we know that the cross-section area is 64.98 times extension, this length here, which is our height, 3 centimeters. So this is centimeters squared and this is centimeters. So if you multiply, you will get that 64.98 times 3. That will give us 194.94 centimeters cubed. So that is the volume of this. That is the volume of the nut, of a regular hexagonal nut. Yeah. So that's how we do it. So just to give some clarification, what we have done, we say that what you need to do, you need to know which is the cross-section area, and then how to get the area of the cross-section area. So because we have been told that this is a regular hexagon, so we have to subdivide it into triangles. And we know that the number of triangles that you obtain will be the same as the number of sides of that polygon. And having done that, then now you know that the angles at a point add up to 360 degrees. And because here you have how many triangles? 6 triangles. So we say 360 divided by 6. That will give us one angle of the triangle, or angle at the center. This angle here at the center of the circle. The angle obtained at the center. So that we got it to be 60 degrees. So if it is 60 degrees and we were given only one side, that is 5 centimeters, we know that we need now to get the area of that triangle. And in case for a hexagon here, you see that it is equiangular, because if say 180 minus 60, you get that 120. 120 divided by 2, the base angles will be 60. So the triangle for a hexagonal polygon, the triangle is equilateral triangle. That means the angles are equal and also the sides are equal. So we can use any formula there to get the area of one triangle, and you multiply by the number of triangles, and that will give you the area of the cross-section area. To get the volume, you say the area of the cross-section area multiplied by extension. That will give us 194.94 centimeters cubed. Thank you.